All right, here we go. This is problem 64 from chapter 9 of the Halliday and Resnick book. So we've got a steel ball. We know that the mass of the ball is 0.5 kilograms. It's fastened to a cord that is 70 centimeters long. So for us, why that's important is basically this thing is going to be falling from a height of 0.7 meters, right? So in a minute we're going to use some conservation of energy. So our height is 0.7 meters, 70 centimeters. All right, it's fixed at the far end. The ball is released when the cord is horizontal. At the bottom, the ball strikes a steel block. So the mass of steel is 2.5 kilograms. And the velocity of the steel initially is 0. All right, and then the collision is elastic. All right, so what we need to do is we need to find, at the end of the swing, in other words, before the collision, what is the velocity of the ball. So for the swing, here's what we know. I know that during the swing, the potential energy that I start with is equal to the kinetic energy I end with. So m times g times 0.7 meters equals 1/2 m times v squared. My masses cancel. Solve for v, and you will discover that that velocity is 3.70 meters a second. And that is important because that becomes the velocity of the block before the collision, or the ball rather, before the collision. Okay? So let me go over here and let's kind of make a new little chart over here. So we got ball and we got steel. I know that the velocity of the ball initially is 3.7 meters a second. I know that it has a mass of 0.5 kilograms. I know that the velocity of the steel initially is 0, and the mass of the steel is 2.5 kilograms. So from here, this just becomes a conservation of momentum system of equations because it's elastic. Okay, so let's clear up some space here. So here are my two equations. So first of all, let's see. I know that the velocity of B initial plus the velocity of B final is equal to the velocity of steel initial plus the velocity of steel final. And I can plug in my numbers to find out that 3.7 plus the velocity of the ball final equals the velocity of the steel final, right? Because this guy is 0. Okay, so that is equation number 1. Equation number 2 is going to be this. The mass of the ball times the velocity of the ball initially plus the mass of the steel, because the velocity of the steel initially equals the mass of the ball times the velocity of the ball final plus the mass of the steel times the velocity of the steel final. Let's plug in some numbers here and see what we get. So the mass of the ball was 0.5. The velocity of the ball initially was 3.7. The mass of the steel is 2.5. The velocity of the steel initially was 0. Mass of the ball was 0.5. Velocity of the ball final plus the mass of the steel is 2.5 times the velocity of the steel final. So now what I'm going to do is I'm going to substitute this into here. So this whole mess gives half of 3.7, which is what, 1.85 equals 0.5 times the velocity of the ball final plus 2.5 times 3.7 plus the velocity of the ball final. So here's what you get. You get 1.85 equals 0.5 VBF plus 9.26 plus 2.5 VBF. I should stop here because you guys can finish the algebra. So you're going to subtract 9.26 and then combine the like terms. So you get negative 7.4. I guess 7.41 equals 3 times VBF. So divide both sides, and the velocity of B final ends up being negative 2.47 meters a second. And so then I can find the velocity of SF just by adding 3.7, and you get 1.23. All right, so there you go. There's your answers.